help you fill in this table that's on page 5 of the momentum structured notes. So it looks like there's a lot of gaps missing in this table here. And the thing that you're going to have to use to fill in those gaps is the momentum impulse equation. And the momentum impulse equation is pretty straightforward. In fact, it's given on the table. Impulse is the product of the force times the change in time. So if you multiply this times time, force times time, you will get impulse. Momentum, now remember that momentum is mass times the velocity, but in the impulse momentum equation, it's actually the change in momentum. So you'd have to have a change in velocity. And if you look across the top of this table, it shows change of velocity with the triangle P, which is the abbreviation for momentum. And you would take the mass times the change in velocity. So if I wanted to fill in this square for the change in momentum, I'm going to take the mass, 10 kilograms, I'm going to multiply it by the change in velocity. Now this means that it's slowing down because you have a negative value there. So it's okay to have negative values here. I think I'll use blue here. So the 10 times the 40 is going to give me minus 40 for my change in momentum. But because the impulse and the change in momentum are the exact same thing, so these two quantities are the same. So the impulse would also be minus 40, but that's measured in newtons of force times the seconds. Now, if you have the time interval here, then you would divide the impulse by the time interval. Okay, now let's back this up a little bit, and down below, let's give you a circle equation for each of these, and it would make it a little bit easier for you to fill those things in. Let me erase that stray mark there. Go back to this. And if I put a circle equation in, that's a pretty good circle. It's not great, but it's a pretty good circle. And if I have impulse in the top part of this, and in the bottom part, I have force and change in time. Now remember that when you're solving for something using these circle equations, you're solving for the newtons of force. So you would put your finger over the F here, and so you would take the impulse divided by the change in time. So the formula would be impulse divided by delta T is going to give you the force. So by taking negative 40 divided by 0.010, then when you calculate that out, then you would end up with the number of newtons of force that it takes to have that kind of change in momentum and that amount of impulse. So likewise, if we're going and we are given this value and given that value, then once again, I'm going to have negative 40 divided by 0.10. Now, hopefully you remember that dividing by 1/10 is like multiplying by 10. So you would end up with 400 newtons of force. And it would be a negative value, 400. I may make that a little bit smaller here. Okay. And this was from negative 40 divided by 0.10. Here we go. And you can simply copy over the change of momentum from the impulse. That's the same. And it looks like this value here is the same. So it looks like I'm going to have the velocity then. And if I have a circle equation for the other side, I'm going to have the change in momentum is equal to the mass in kilograms and the change in velocity. So if I want change in velocity, it would be the change in momentum divided by the mass. So change in momentum is minus 10. I'm going to divide that. Minus 4, excuse me. I'm going to divide that by 10. And that's going to give me the same value.